All right, so let's get into one of the absolute wildest ideas in modern physics. I'm talking about time crystals. Yeah, you heard that right. We're about to explore a completely new phase of matter that seems to, break all the rules, but in the most fascinating way possible.
It really all kicks off with a quote like this: a new state of matter that shouldn't exist. Now, that's not just some clickbait headline. It really gets to the heart of why this whole idea sent such huge shockwaves through the science world. Honestly, it sounds like something straight out of a sci-fi movie, but as you're about to see, it is very, very real.
Okay, so what is a time crystal? Well, you're definitely familiar with regular crystals, or what we call spatial crystals. Think of a diamond, right? Its atoms are all lined up in this perfect repeating pattern in space. A time crystal does something kind of similar, but in a totally different dimension. Its pattern doesn't repeat in space, it repeats in time. Imagine a drum that, after you tap it just once, keeps a perfect, steady beat forever, all by itself. That's the core idea we're dealing with here.
So, where did this mind-bending concept even come from? I mean, this isn't something someone just stumbled upon in a lab. It was actually proposed, way back in 2012, by the Nobel laureate Frank Wilczek.
Wilczek's original idea was just so elegant. He imagined a system that, even at its absolute minimum energy level, what physicists call its ground state, it would just tick. It would keep oscillating on and on, with absolutely no energy being put into it. It's basically a perfect clock that never needs winding and would just run forever. Pretty wild, right? But, and this is a big but, there was a huge problem with this beautiful idea. It sounded an awful lot like a perpetual motion machine, which, as we all know, is a giant no-no in the world of physics. So understandably, the scientific community was super skeptical, and for a really good reason. And this timeline shows you exactly why. Just a few years after Wilczek proposed the idea, a bunch of physicists published what they call no-go theorems. And these aren't just opinions, they're hardcore mathematical proofs showing that a time crystal in thermal equilibrium, a stable, isolated system just sitting there, is completely, totally impossible. Why? Because it would violate the second law of thermodynamics. It really seemed like the door had just been slammed shut on the whole idea. But then, scientists did what they do best. They found a loophole, a brilliant pivot in thinking. They asked, okay, what if the time crystal wasn't in that perfect, isolated state of equilibrium? What if it was being actively pushed? And this is the absolute key to understanding this. An equilibrium system is isolated. Think of it like a coffee in a perfect thermos, just left alone. But a driven system is constantly getting little nudges of energy from the outside, say from a laser that's pulsing on it. And what this means is that time crystals don't violate thermodynamics at all because they are not isolated systems. Energy is constantly being pumped in. This changed everything. So this brings us to what we now call a discrete time crystal, or a DTC. And here's the really weird and wonderful part. It's a system that you push with a certain rhythm. Let's call it every t seconds. But instead of just going along with your rhythm, it spontaneously adopts its own beat, one that's a multiple of the push. So it usually settles into a rhythm of every 2t seconds. It's like you're tapping a drum once every second, but the drum decides, nah, I'm only going to sound off once every 2 seconds. It just creates its own more stable rhythm. So how in the world do you actually build one of these things? Well, here's the basic recipe. First, you start with a jumbled up, disordered quantum system. Next, you drive it, you push it with something like a laser at a steady rhythm. Now, here's the secret sauce. You use a weird quantum effect called many-body localization. You can think of it like this. Normally, if you keep pumping energy into a system, it just heats up and turns into chaos, like boiling water. But this many-body localization thing, it prevents the system from absorbing that energy and overheating. It allows it to stay cool and lock into that new, stable, doubled period. And this recipe, it wasn't just a cool idea on a blackboard. It became the actual blueprint for one of the most exciting experiments in recent physics. So let's take a look at how this mind-bending theory was finally brought to life. And then, in 2017, it happened. Not once, but twice. 2 different research groups working completely independently created the world's first time crystals. A team at the University of Maryland used a chain of ions, zapping them with lasers. At the exact same time, a group at Harvard was using tiny defects in a diamond, pushing them with microwaves. And what did they both find? A stable, robust oscillation at exactly double the period of their push. I mean,
Two totally different setups, two different methods, but they got the exact same incredible result. Time crystals were officially real.
This is all amazing, of course, but it leads to the big question. So what? Why does creating this bizarre new thing actually matter? Well, it turns out the implications they're pretty profound.
Okay, let's break down why this is such a game changer. For fundamental physics, it literally expands our definition of a phase of matter itself, moving it into the dimension of time. Then there's technology. Their incredible stability makes them amazing candidates for quantum computing. We're talking about super robust qubits or quantum memory that are naturally protected from errors. They could also lead to unimaginably accurate clocks and sensors. This discovery doesn't just add a new fun fact to the physics textbooks, it opens up an entire new field of science.
And that really brings us to the big takeaway here. The existence of time crystals forces us to ask some really deep questions. I mean, if matter can organize itself in time, creating its own persistent rhythm, it just makes you wonder, right? What other fundamental hidden properties of our universe are just sitting there, waiting in plain sight for us to discover next?